So as we look at Module 4, you're going to notice that the heading says Section and Auxiliary Views. So this evening, we're going to be looking at Session 1, which was going to be section views. And then the next time we get together, we're going to be looking at auxiliary views. And basically what it is it's different ways of looking at the part when we can't get at the information with just the standard views that we have available to us. And that happens. So these are some ways that we can see more versions of the part. So tonight we're going to be looking at chapter 8 in your Gajewski book, which is going to be kind of the rules and the vocabulary and the things you need to keep in mind with section views. And then we're also going to be looking in AutoCAD at chapter 10 and doing a tutorial and showing you how you would then translate that to AutoCAD through, and that's going to be one of our practice problems, okay? Then the next time we get together, you're going to notice in session 2, that's where we're going to talk about auxiliary views, which is going to be chapter 9 in our Gajewski or that tech drafting book. And then we're going to be looking at chapter 10 in our AutoCAD book to then do some auxiliary view work. And that's going to be the tutorial that we see here. So when we look at the practice problems for module 4, there are actually 2 problems we're going to do. One from chapter 11, which we're going to be doing tonight. And then the next time we get together from chapter 10. Okay. So we'll have to just kind of wait until after session 2 to get both of the tutorials on there for the practice problems. For our assignment 4A, this is going to be pertaining to the items that we talk about this evening. So this is going to be a couple section views that I want you to do. These are at the end of chapter 10. Okay. And this is out of your AutoCAD book, and then you've got some drawing guides here as well, okay? And then assignment 4B then is, oh, it says chapter 10 here too. I'm gonna have to look at that. This is gonna be, 4B is gonna be the auxiliary views. Let me take a peek here. I've got 10. I'm a little bothered by this. 10 is the section views. I think it's 11. 11. I think is the auxiliary views. Let me look. Oh, it's 9, chapter 9. I will update the auxiliary view information. It will be chapter 9 information. So I'll get those in order. But tonight is chapter 10 and chapter 8. So let's take a peek at our agenda 1. And I am going to open up our PDF, and this is going to be guiding us through the chapter in our tech drafting book. Okay, so this is chapter 8. As we look here, I'm not going to read each and every one of these to you, but it's about section views and when they would be used, why we would be using them, and the elements that we have to keep in mind when we generate them. Okay, when it's something that we're going to end up doing. So section views, a very overall kind of a great example that we can relate to is when we create a section view, we want to look at what's going on the inside of this part, because when we look at the views, we can't get at that information like standard views. So we're going to, if you would, cut through the part so that we can see the inside. Kind of like when we have, for instance, this is a melon in this case, or an apple, or an orange, and we cut down the middle of it, we get a very different look at what's actually going on the inside than by just looking at the outside of it, okay? So we're also going to find out when we do dimensioning next week that we cannot dimension to hidden features. So sometimes we have to make a section view so that we can dimension something that's kind of on the inside of the part where we end up not being able to get an edge to it, okay? So when we create a section view, we have to tell everybody where we're cutting through, and we are going to use cutting plane lines for this. Okay, I want to make sure I have everybody's attention. Okay, that we're on task here. You can always work some more on the items we were working on earlier, but right now I want to be sure you get this information because we'll be applying this in a little while to the CAD work that we do. So cutting plane, what's a cutting plane? Cutting plane tells us where we're going to be cutting through. Now on a drawing, the way we represent a cutting plane is we're going to have a line going through, and then we're going to see arrowheads, okay, on either side. The direction of those arrowheads is very important, okay? The direction of the arrowheads is important. We always place our section view, we say, in back of the cutting plane lines. So if the cutting plane lines are pointing, in this case, to the left, our section view is going to be on the right side, okay? If they would be pointing in the opposite direction, if the cutting plane lines are pointing to the right, then our section view would be on the left, okay? So it is important to keep in mind. Now, when you do section views, for instance, in parametric software like 3D modeling software, which is where you're going to be going, soon after this class, they're a little bit, I'm not going to say they're more intelligent than us, but it automatically puts them in for you. Okay. But when we're in AutoCAD, we manually put them in. So it's going to be important. That's something I'm going to be looking for. Are the cutting plane lines, the arrows on the cutting plane lines in the correct direction for where you have your view? Okay. So if I'm pointing to the left, that means my cutting plane view is on the right. Okay. Now, something you're going to notice here about our cutting or our section view is that there are these lines that are like what we call hatching. And in SolidWorks, or I'm sorry, in AutoCAD, that's what we're going to do. We're going to use the hatch command. Now, that hatching represents material that we would cut through. So physical material that is actually getting cut is anything that you see here with the diagonal line on it. Okay. Anything that's not getting cut, it's like that was air. All right. But what it creates for us is it creates these visible edges along things where now it opens up the opportunity to dimension to those inside of the part, where otherwise there would be hidden lines. And one of the rules of dimensioning is we can't dimension to hidden lines. So we have to create a view like a section view to be able to see the insides of a part with visible lines so that we can dimension to them, but also add clarity and give us a better look at what's going on the inside. The other thing you're going to notice is that we do not put hidden lines in a section view unless they add clarity. Okay. So, but for the most part, we do not add any hidden lines to section views. Okay. They stay away. So you're going to notice that here, it kind of cleans up everything. We don't see all the clutter of the hidden lines that would normally be there, but now we can dimension to the visible edges that we see here. Here's another look. You're going to be creating I think it is this part is going to be one of your assigned items for your homework. But here you're going to notice that we have a section view going through here, but we don't have any cutting plane lines. You can, per the standard, avoid putting cutting plane lines when you have a full section and it's the only section on the drawing. I would advise against that. It's just more clear when you have the cutting plane lines here. You might think, are they that important? Yeah, I think they are, but this is legal. This is legal, and it is okay to do that when you only have one section going, full through, and it's a symmetrical part as we see here. Okay. Placement of the section view. So again, kind of reinforcing here, you're going to notice that our section line is pointing to the right. Our cutting plane line is pointing to the right. So that means that our view is going to be on the left. The arrows give us, if you would, our line of sight. So we're cutting through the part. We take away this left side, okay? And we want to see, okay, when I look this way to the right at that part, what do I see? Okay, and that's what our view is showing us. And again, anywhere we see these diagonal lines, those are called cross-hatching, and those represent material that we physically cut through, okay? And then the voids are going to be where exactly that. There isn't any material cutting through, but then we see the edges of the internal features, okay? Now, in this case, this really kind of clears things up. I mean, we would see a lot of hidden lines in this case going around. And by putting the section line through, now we can focus on just what those inside elements are, and we can see them as actual edges. Okay. Again, thinking of fruit, when we cut through the fruit, we can all of a sudden see, like in the instance of an apple, we can see the seeds on the inside. We can see the core. We can see where the stem comes out. Where otherwise, if we just look at the outside, we wouldn't get that same information. Now, labeling cutting plane lines. The rule is you start with the letter A is going to be the first section view or the cutting plane lines that you assign, then B, then C, then D, and so on. You go in alphabetical order. You do not start in the middle of the alphabet on a new drawing. So you always, your first cutting plane lines are going to be A's, your second ones are going to be B's, and so on, okay? Now, so you'll look here, you'll notice that we have a part. We do have multiple cutting plane lines in here, okay? Now, you'll notice that we have A, that we're pointing up in this case. So notice that down below is where our section view here is for A. Also notice the labels here. In this case, we have A on each side of the cutting plane lines. And then down here, the label for this view is called section A-A, okay? Now, when there's only one section, okay, like we saw, I'm going to go back actually up. I'm going to go up here. We can put the cutting plane lines in, and I always encourage you to do that. Again, you can make the exception, but most often you see that. But notice there is no label on our cutting plane line here, okay? That is because it's the only single view in this drawing, and it's obvious, like that's the section that's being created. But when we have multiples, okay, now it's important to label which view is which, okay? So in this case, we have A directly below, and then we have B over on the side. Now, one of the rules about section views that you can put them in orthographic projection, but they don't have to be, okay? So you'll notice here for view BB, we are going and we're looking to the left. You might say, well, why didn't you put it up here and look in that direction? I don't know. The person who drew it didn't, but the exception is for section views, they don't have to be in projection. We can actually kind of maneuver them and put them wherever on the drawing we have room, for instance, okay? So we could rotate this and put this in projection with B in this case, but it is also totally fine to have it as its own independent view, not in orthographic projection, okay? So both are okay. Both are okay. Many times we'll take it out of projection when we're using that side view already. So for instance, if we're using a right side view up here with that top view, and we would show it as its regular view, but then we would put a section view and we would put it off to the side, it's probably for the reason of being able to dimension or see inside features that we wouldn't be able to otherwise, okay? So sometimes you have those in combination. So the orthographic projection rule, if there is something already there, it allows you to put the section view wherever it seems to make sense on the drawing, okay? Now, lines and sections, okay? So as we look at this part right here, everything looks good. You'll notice that we have our section lines going. In this case, they have them pointing up, so our view is down below, okay? So it's in the correct projection. You'll also notice that wherever we have hatch lines, the border is always an object line. So it's a solid line. We never have hidden view or hidden lines in a section view, especially where we would be hatching to, okay? You actually see that case right here. This is wrong, okay? And I'm glad they use that verbiage. It is wrong because you'll notice that there are hidden lines in the place of where the edges are, okay? We never, ever cross hatch to hidden lines. Now, if we start at the top here, you're going to notice that they have the section view and they're showing just the areas where the cuts are on the material. But now it looks like all those are floating, right? So as you can imagine, what they're missing are the edges that we end up seeing. And then it makes it look like an actual part is connected, okay? So this is not a complete view. So this is not even poor. This is wrong, okay? The next one that we see here, I would say would be poor because you'll notice that they added hidden lines here. You really want to take those out unless they're important for some reason, but most often they're not, okay? If you do need the hidden lines and you want to create then just an extra view that is going to have those hidden lines in, that's one of our principal projection views, and then do a section view in addition to. We already talked about the hidden lines here. The other thing that you're going to see here, now this isn't quite as obvious, but this is wrong as well. You're going to notice that the direction on the hatches on one side of the part are going up and to the right. And then on the other side, they're going down and to the right. Sorry, up and to the left and down and to the right. So they're going in opposite directions on a single part. They have to go in the same direction. You're going to notice here on the left-hand side and the right-hand side, the direction or the angle of the hatching is all in the same direction, okay? So you can't change the direction on a part. And then the very last one here is you're going to notice that you have a line going over the hatching. So what they've done is they've extended this like you would see a principal view, and they forgot to take this line out. You do not put those lines, visible lines, across any hatching. It's going to be the outline of the material that you would actually be going through, okay? So the one over here on the left-hand side is perfect. It's got everything in place as it should be. Notice as well that we do use center lines in section views, and they are going to show the axes of any cylindrical features. And then they're handled the same way, where there's a little bit of an extension on one side of the part and then a little bit on the, in this case, on the bottom of the part. We make sure that we always extend our center lines past the actual part itself. They go further, okay? Now, cutting plane line style, we did the cutting plane line to the current drafting standard, which is dashed lines, okay? The old way, but also still an acceptable way, is to use what we call phantom lines, where you have a long dash, then you have two short dashes, then a long dash and two short dashes, and so on. So either one of these, but the current standard is the dashed line. So that's what we've adopted in our templates that we set up in AutoCAD. Visualizing cutting plane direction. So again, this is just kind of going over where, thinking about when I cut the part, the arrows are telling me which way I'm looking. And that's why on the left-hand side here, it's kind of like taking away this right side and now pointing in that direction, looking to the left, what do I see? Okay, so my arrows are pointing to the left. My view is to the right. They're always in back of the arrows, okay? Over on this one, notice that the arrows are pointing towards. The view would have to go on the opposite side, okay? And here again, they're pointing towards. It would have to go on the opposite side, okay? So be aware of that. In AutoCAD, you manually put them in place. That's why it's important, because I will be looking to make sure that the arrows are going in the correct direction, okay? That is important. In other parametric software, like I said, when you model, they usually take care of that for you, but you always want to check just to be sure it's right. All right, the next one here is section line technique. So first of all, as we look at our section lines, and again, AutoCAD will be doing a lot of this for us, but it's important to kind of point it out. First of all, the outside area here, we don't extend our hatches to the outside of that area. When you manually draft it by hand, I guess there's more of a chance that you might go outside or not quite get to the outline. But in CAD, as long as you've got good geometry, it will fill in appropriately. Now, as far as the spacing and the angle, depending on the parts that you have, if you have parts that there are 45-degree angles on it, and these lines are at 45-degree angles, you're going to want to change the angle of the crosshatch so that you can see the difference, okay? And we'll see some examples of that coming up. Additionally, you want to make sure that the spacing itself is appropriate for the size of the part. And that's going to be one of those things that when you look at it, you're going to just kind of decide, is that, you know, proportional or not? You don't want things to be too close together or too far apart where you can't see the cross-hatching on it. So we'll kind of get used to that. We'll show some examples of that when we do it in AutoCAD and how you can change that and what looks best. Additionally, you're going to notice that, you know, spacing is irregular. You're not going to have that opportunity in AutoCAD because, again, it's already kind of set up for us. It's a matter of scaling it. But again, we don't want them too close together. You don't want varying line widths. Again, AutoCAD controls that for us. We already set up our template so that the line is correct and that they're not going to go outside. The only way they would go outside of an area is if your geometry isn't coming together at corners and making sure that you don't have overlapping lines where it might get confused at where is it that I want to hatch, okay? But if you've got good geometry and good line work, you'll be totally fine. It'll do it nicely. So section views techniques, and this was what I was referring to. So for instance, when we have a part where part of the feature is at a 45-degree angle already, You do not hatch so that it goes along that same line. You want to change the angle here so that we can see where that material ends. Otherwise, this gets hard to distinguish between the hatching and what the actual object lines are, okay? Another rule is that you don't go 90 degrees to any one of the surfaces, but again, you just want to make, this is the one in the middle is really the worst case scenario here. Now, section line symbols. Now here, this used to be more important, I'm going to say, in the olden days, where there was different types of materials like steel and cast iron and aluminum, and you would have different hatching depending on the material. That is not as prevalent nowadays, especially with CAD systems, as it had been in the past, okay? So you'll just kind of pick the type that you want for the part. When you get into assemblies, that's when we're going to be making sure that as we go from part to part, that if we put a section through, that we have different cross-hatching patterns as well as kinds so that we can see the difference between parts, okay? But here you're going to notice that you can use sections for anything from mechanical things, like when we work with metal parts or, aluminums, copper, bronzes, but then also other disciplines like the construction trades. You're going to see that there's sand and water and earth and rock and stuff. So those are all available, different types of hatches to distinguish between different materials. But again, we're going to notice that we don't stick hard and fast to that. Most often it's like what looks best, honestly. You can also have, rather than a full section, you can have a half section. So there might be just a portion of what you want to look at. So in that case of the melon, instead of going all the way through, just taking a chunk out of it, okay? And that's really what it equates to here for a part that we see. When we draw that and we take that quarter section out, what ends up happening is we just see a section on one side to kind of get that feel for what's going on the inside. And then on the other side, we see it as, its normal part, if you would, like the outside. These are nice, again, when you would want to kind of preserve what that part looks like, but then also want the ability to be able to identify items that are on the inside or dimension to those, okay? Breakout sections are also ones where we just want to look at a portion of what that part is. So instead of creating a full section through the entire thing, we just want to see a small detail of it. So you can break out a section and then make an enlarged view so that you can dimension to it, okay? Another one is a revolve section. This is going to be when we have different cross sections. In this case, we're going to notice that we have kind of a cross section of kind of a cross area here on this spoke of what looks to me to be like a wheel. And instead of creating an entire additional view to show that, they're actually breaking it out, they're rotating it, and this gives us the opportunity to dimension it right in that very same view. Okay, you guys won't be doing these as part of assignments that I have you guys doing it to. It's probably a little bit more, I want to say, an advanced subject, but want you to be aware of them when you see them. Okay. Removed fact section is going to be one where, again, we're kind of looking at something, a smaller part in this case, we're sectioning it out and then we're enlarging it so that we can see, greater detail of what's going on there. So this is called a removed section. Notice it's not an orthographic projection because physically it's 4 times larger in this case, so that again, we can get a better view of what's going on. Many times when we have small parts and we're dimensioning it in the view, we physically can't get all the dimensions in there and make sense of what's going on, okay? So making an enlarged section view like we see here is something that's very popular to do. I believe this is the last type of section view. This is called an offset section. An offset section, oh no, it's not. There's going to be 1 or 2 other ones now that I'm thinking of it. So an offset section is when we are going through and instead of having a straight line for our cutting plane line, we're kind of like taking some jogs. So you'll notice here that we start our section line, our cutting plane line going through this hole. But if I would continue going through, I would be cutting, and I would only get one other element. Well, to be efficient, if you would, in the section view, notice that we jog up. This is a 90-degree cut, a 90-degree jog, and then we're going to go over through the slot, jog up one more time, go through this element, looks like a counter bore of some sort, then go back down through the hole and then look. This allows us, instead of having 1, 2, 3 section views, we can get it all done in one, but you have to be sure that you put your section view or your cutting plane line in there appropriately so that everybody can see what you're going through. And again, it's just for the purpose of dimensioning and not having, you know, a bunch of different views. Now, ribs or webs, these are kind of special in that when we section through a web, so if we look here from one side, we go to the other, as we go through the actual length of the web, technically we're cutting through material, but if we show it cutting through the material, it looks like it's a solid part, and it's not, okay? There is a web, you can see it right here from the top view, there is a web here where this portion you don't actually show it cut, okay? So that is one of kind of the special exceptions. You do this for ribs and webs on parts. The next one that we look at here is called an aligned section. So you'll notice here that we have kind of this foot, if you would, it's at an angle. And if we put a section view through there, like a full section view through, we wouldn't get this detail here. But you'll notice that it's at an angle. So what we end up doing is we actually end up rotating it to be aligned to the axis here, and then we project over. It gives us a better view of how small or large that part would actually be. So if you notice here, there's kind of like this length here before we get to the hole. We mimic that in this section view as well. Okay, so that's called an aligned section. Kind of on that order of a quarter section where you have like a partial views here. This is kind of just looking at certain areas and also revolving the material so that we can see what the cross section looks like right on the view. And then the break lines here. You're going to notice that 4 cylindrical features that are a solid round, we're going to have the type of section lines that you, or the break lines that you see here, as well as if we have tubes. And then if you have a round tube that's really long, we can also just cut it at the angle that you see here and then show the section lines for the view that we would have. And then lastly, this is an assembly section. When we have parts that come together and we want to show a section going through them and they're individual parts, notice over on the right-hand side here, we have 2 different cross hatches for the 2 different parts. This is to show that they are 2 individuals. If we would have the same cross section going in the same direction, it would be hard to distinguish which part is which, that they weren't separate parts. But in this case, having 2 different cross sections gives them the identity that they are 2 separate ones in an assembly. Okay. So that takes us to the end of kind of the, you know, what we would be expecting to see for section views and kind of what the rules are. So what we're going to do now is we're going to shift gears. I'm going back to our agenda. We're going to open up and we're going to look at chapter 10 in our AutoCAD book. And we are going to be doing the tutorial in chapter 10 to kind of walk through this and kind of apply what we've been learning here in our tech drafting book to how we would translate that to AutoCAD. So I'm going to stop the recording here, and then I will be back with our CAD.